This is part 2 of the 2013 annual stormwater training for the County of Ventura. This section will identify construction issues and go through a bunch of construction site examples in regards to BMPs that can be seen and expected to be seen and fixed on different construction sites. First one I want to identify is just SE-1, which is the nomenclature from the Casca BMP handbook, and this is for silt fence. This is a standard BMP that's placed on many sites, and just wanted to go through a couple issues with them. For instance, they need to be located on level contours, not perpendicular to contours, and they're not for concentrated flow areas. They're not heavy enough or durable enough to be able to withstand high flow rates, so they're more used for perimeters. And it's in the bottom right, you'll see the picture there showing that it really needs to be keyed in. And the great thing about those Casca BMP handbook and that manual is if you go to the SE1 in there, it shows you the proper methodology of installing it. So it's one thing to be on site and looking, okay, it looks all right, but is it installed correctly? If it's not installed correctly, it's not going to be efficient. So it's things like that that you need to be able to become familiar with the Casca BMP handbook and maybe even have it with you on site just to verify that these things are actually installed correctly. Second one is SEE10, which is inlet protection. Again, very standard on many construction sites. These are two good examples of different protection of inlets, different types of inlets. So on the top there you have a drop inlet that has various rows of berms using fiber rolls and it looks like gravel. And on the bottom you have your standard curb inlet for a street, which has the filter fabric laid down as well as sandbags around it. The one key thing I want to point out is on the bottom picture, the filter fabric should not be used during the rainy season. That's strictly during the summer season, so dust doesn't get into there. But if you keep it on during the rainy seasons, then it could contribute to flooding, and it really needs to be removed. The temporary construction entrances is another staple of construction sites. Every single site must have it in order to keep track out of mud and that from the construction site to the public right-of-way to a minimum. And again, the TC-1 within the Casca BMP handbook should be referenced for identification of how it should be constructed, approximate lengths, and you'll see in the picture on the top there is a very good entrance. It's got the high coarse gravel all the way through. It looks like the only entrance to that site where both ingress and egress goes through that same entrance. And on the bottom picture, you'll see there is no gravel. They just have these shaker plates which can move around, and additionally there's space on either side of the shaker plates, meaning that some vehicles may be able to bypass the entrance altogether, which is not the best use for these. We need to make sure that all vehicles entering and leaving the site cross over these construction entrances. WM8 concrete waste is another staple of most construction sites. It outlines the proper way to create a concrete washout area and to make sure that contractors are using them. Concrete ends up spiking the pH in stormwater that leaves, and obviously the pH in water, if it's too high or too low, depending on certain ranges, can kill fish. So it is very important that we keep all construction waste in a contained area that does not have the chance of leaving the site. And WM8 of the Casca BMP handbook outlines the best methodologies for doing that. EC4 is for hydroseeding. At the end of a project, you'll see lots of slopes. Obviously, they will get hydroseeded at times, and then irrigation will get built up to make sure that the seeds germinate and vegetation actually grows. With EC4, you often see various types of other BMPs utilized at the same time, such as mats or jute netting, to make sure the slope stays stabilized while the hydroseed is germinating with the irrigation. And you'll see other things at the toes of slopes, such as riprap or overside drains, to make sure that if water is going over that slope, that it's at least concentrated in a non-erodible fashion. Here are some common construction site blunders we'll kind of go through, and these will show you a bad scenario and then a good scenario. So you get an idea of what you can look at through construction sites and what's good practice and what's poor practice. This is a inactive slope with no slope stabilization. As you can see, there's a lot of rutting and rilling, and it looks like what had happened is they had no perimeter control on the top of that slope, And the construction site obviously had a lot of water during the rainstorm going over top of that slope, which ate away the slope on the back side of it. So this obviously is a bad practice. Here's a better practice, is you see the silt fence at the top of the slope, so that water isn't supposed to go over, but if it does, they still have the jute knitting they're placing down, which will keep the soil in place and stabilize the slope as best as possible. For site perimeters, often you'll see this, contractors will install something that looks great for a week and it starts getting damaged and they don't touch it again. But this is one key point of all these SW1s and SW2 and SWIPs, is that maintenance of the BMPs must be kept up throughout the duration of the project. So in this case, you have a silt fence that's tipping over, it's got gaps in it, it's going to be not very efficient. And of course you have the gravel bags on the right side, which are dumping gravel directly into the concrete V-ditch, it looks like. So all these items need to be maintained throughout the duration of the project. This is better practice for perimeter control. On the left there you have gravel bags with silt fence behind it, and then on the right there you have the fiber rolls around the whole perimeter. And you can see everything looks very clean. The one thing I want to point out here is the straw wattle there on the right picture. Typically, if you look at the Casca BMP handbook, they will be staked, as well as they'll be trenched in slightly. I guess 1/3 of the height of the wattle should be trenched in so that it's actually effective and water doesn't flow underneath it. For dust control, it's obviously a major issue, especially with projects within city limits, things like that, where residents could be distraught over dust when they're trying to drive home from work. And you just need to make sure that they're using water on site, and you just want to ensure that water being used on site is not being used excessively to the point where it'll actually create runoff, which is considered a non-stormwater discharge and is not authorized by the NPDES permit. For stockpile management, it's required that they're covered when they're not used is good fashion, and here you see there's no perimeter control around either of them. Typically with these you'll see they're covered in plastic, usually the 5 mil impermeable plastic, and then gravel bag berm or some sort of barrier around it to make sure that if water does fall on it, that the sediment still is not leaving that general stockpile area. And here's an example of what I was talking about. Here's two good examples of stockpile management, making sure that there's a berm around it so that first no run-on can get into the stockpile and take that soil away from you, or water hitting that stockpile doesn't leave as well. For inlet protection, here's an example. Obviously construction is going on. You can see the stock cutting machine or on the street there, and there's obviously track out on the street, so you know construction's going on, and you just need to make sure that all BMPs that are called out to be used are actually being used properly. Here's better practice for the inlet protection. Again, gravel bags or sand bags all the way around, or gravel bags, but the filter fabric again should be taken out for the rainy season. For streets and sidewalks, here you see there's no perimeter control, and they haven't been cleaning up at the end of the day, so they have all this washout over the street and it just looks really dirty. And here's a better practice. Obviously they have good perimeter control. They've most likely been sweeping up at the end of every day, and you have the perimeter control that's in good fashion, doesn't need to be maintained or replaced at this time. For the concrete washout pits, it's very frustrating seeing this on construction sites, where you, especially on the right there, you have an identified proper concrete washout there on the black, and they wash out right next to it. So it's one thing that on construction sites you need to make sure that not only the contractor knows what they're doing, but they're talking to the actual operators of the concrete trucks to make sure that they're washing out in the correct locations. Here's better practice. The easiest way to actually do it on construction site is on the left side, is to get those roll-out containers to the site. Just cover it with liner and just get it out of there, and it's the easiest way to dispose of it. The more permanent ones, which can be used over and then over again, on the right there, you can then remove the plastic, put new plastic on, and remove the concrete as appropriate from the site. For leaking equipment and any kind of equipment, vehicles that are idle, they need to be placed over top of drip pans, and those need to be functional drip pans. For instance, here you'll see there's in the top left there's leaks on the ground, top right there's damage to the drip pan, so it's ineffective, and the flat oil trays in the bottom left, well obviously oil's going to hit it and just sheet off. Same with the plastic on the bottom right. there's no berm around it, so any kind of oil, any kind of things that comes off of those vehicles is going to sheet flow off of that and become a pollutant on the site. Here's better practice, putting drip pans under all idle equipment to make sure that there is, in case of like a hydraulic leak or anything like that, that it is covered. For trash storage, all dumpsters and trash cans need to be covered, especially when there's a storm predicted, and they need to be emptied so they're not overflowing. The main reason, obviously, everything from a construction site gets thrown in these things, and that could be batteries, it could be anything. You just need to make sure that they're covered, because if it does rain, all that water gets in there and just soups out the bottom, and now it's just a toxic mess or a bunch of different pollutants going through there that need to be contained and or reported if it's illicit discharge, or if it's leaving the site as a non-stormwater discharge. So we need to make sure that these are covered. For dirt tracking, again, these are poor construction entrances, or they're not using them, or they don't even have them installed. This is exactly what we don't want to see, is mud and dirt all over the public streets. Here's better practice for dirt tracking, especially the option on the right there, where it's a very wide entrance and exit. There's no way you can go around those shaker plates. Every single vehicle goes over all the gravel, and there is perimeter control of gravel bags on the side to make sure that nothing else leaves the site from this area. For saw cutting, obviously if you're doing any kind of saw cutting, that you should have inlet protection, things like that, stipulated through the SW1, SW2 forms. The one on the right, the guy's saw cutting with water and not cleaning it up. On the right side is obviously better practice, where there's the one person saw cutting and one vacuuming behind him, so that high pH water does not go into the storm drain. Portable toilets is another one. It's always a mystery to me where contractors decide to put them. Put it right in the flow gutter, or right in the flow line of the gutter. They'll put it right next to an inlet. Lots of times they're not maintained, or they're overflowing, and they're not providing proper secondary containment. And all of these things, whether it's portable toilets or water containment on site, concrete waste, are all outlined within the specific BMPs that are addressed within each of these SW1, SW2 forms. And they can be found within the Casca BMP handbook as to specifics of how to address certain situations and how to best set up your site. Here's better practice. There's no way that either of these could really be an issue on project sites. They're either extremely far away from discharge points from the site, so that if there is a spill, they could easily contain it before it becomes a problem. And lastly, I just wanted to touch again on the locations of these the Casca BMP handbook as well as the Caltrans handbook. Again, both touch on the exact same scenarios, such as the SCE1, SCE2. These have slightly different naming schemes, but they do identify construction methods, how to install BMPs, how often they should be maintained, and things like that. So I'd recommend checking out both of these if you're not familiar with them, and print them out so you can have them on site with you when you're doing inspections.